Okay, so one of the aspects of any machining operation that is not apparent to anybody that doesn't do this in any sort of major capacity is dialing in your machine, dialing in everything. I mean, being a machinist is a lot of work and it's technical. I'm not a very technical person, but I am persistent and I want the best product possible. But also, when you can dial certain things in, you can go a little bit faster and be a little bit more efficient. So, what I'm doing today is actually dialing in the speed. This is just an end mill I've never used before. So when you get something that you never used before, you can either use it just directly on a product, like if you have kind of an idea of what to expect from the material. You can kind of go at the projects and just whatever gets messed up, and that's fine. That's one way to do it. But this plywood is a little bit expensive, so I want to see what it can do, and I have some scraps I can do this on. So basically, I'm just going to be cutting a few little squares down here. So just on this piece of scrap, that's what I have laid out there. There's my little angle on there, and that's just blocks off and tells me where everything is on here. So this is just a piece of scrap. That's a failed cut right there. So we'll just be running that. So we'll run into our little prop program over here, and then we can see our top view is kind of telling us. Oh, there's a glare on the screen, but where's the glare come? I don't know where the glare is coming from, but anyways, it shows us our little square pattern down there either way. So we're just gonna give this a little run, and basically what we're gonna be looking for is actually we're gonna be listening to what this bit sounds like as it's passing through the material. Now, I have up to this point only been doing partial depth cuts, so I might only take a about a 1/4 inch cut, which would only be a very small portion of that thing. So we're going to be taking a much larger cut on this. We're going to be taking 18 millimeters. That's somewhere around there. So a much deeper cut, and that's what I want to stress test here is how fast can I run this bit at full depth through this plywood. And this plywood is very hard to cut through. It's not just regular wood, because even though the wood itself might be easy to cut through, there's a lot of glue layers in this plywood. So, you can look at up feeds and speeds for these bits, what they are designed for. But between this machine, it's not the most rigid machine. There's it is driven by little floppy belts. So it is constrained by the strength of those belts on this little tiny drive motor here. So it's a splined drive with a toothed belt, and that can slip. So that is my upper limit to how much force this thing can put on this motor when it's driving it back and forth and all around. So we're limited to that. Also the speed of this, the strength of this spindle. So when this runs into material, it bogs down the motor. It bogs down the motor of this spindle up here. And that can only, so when that bogs down, well, it's cutting less material down here. And so these parts over here are getting stressed a little bit more because it's not able to, it has to push through the material that it's not cutting down here. So you kind of have to test the whole system as a whole in order to get your real information. So the proof in the pudding is sometimes when you're getting into machining metal, it manifests as chatter when your feeds and speeds aren't right. You can see it in the chips. We can sort of see it in the chips that come out of wood. It's a little bit different because wood doesn't turn into curlicues or straight chips. Now, if you're turning it into sawdust, that's a good indication that you're going too slowly, because it's like a blender versus, like a food processor. So you're chopping the wood. Ideally, you want the most efficient transfer of cutting force into the work. So that's what we're looking for here. So like I said, I'm just going to cut little inch squares, and I'm going to be basically listening to this bit. And the louder it screams, it's not necessarily wrong if it's screaming loud, but it will tell us if there's any bogging down of the motor, when we get to a certain speed. So I have it ramping up after every square. So we're starting at 40 inches per minute, which is pretty slow in CNC machining terms. It's not particularly fast. It's not particularly slow, like if you were doing any sort of carving, like more delicate operation. But I'm testing this for this is a roughing end mill, one I've never used before. It's meant to be shoved through the material pretty much as fast and hard as possible. And so that's what we're going to do, is we're going to see how fast we can shove that thing through the material. And it's going to be, I don't know, I'm not going to have the dust shoe on here, so it's going to be making a big mess, I think. And I won't even have the vacuum system, so you'll get to see all the mess that it makes. And because I just want to be able to hear what kind of sounds it's making as it's making it. So without further ado, I'm going to give this program a little bit of a run. Okay, so that was actually pretty interesting. It seemed to so the one that sounded the best to me actually sounded like I can even see this. It was this one up here. That one sounded the best to me because there was no oscillations in the sound, when it's a nice even sound. That's usually a pretty good thing. Even though it's screaming loud, that means it's not having any not reverberations. I'm at a loss for the word for it, but when it fluctuates in sound, that means it's not cutting evenly. It's kind of stuttering as it's moving forward. There's an oscillation in there somewhere. So what was funny is it was actually cutting too slow on these. And like I said before, it turned this into sawdust. So that's what I was talking about. You don't really want, it's turning all this into sawdust actually. Now that I'm actually looking at it, it is a roughing end mill. So I've never used one of these before. Sorry about the camera. But the sound was really what I was looking for on this, and so it was pretty happy between 70 inches per minute and 80. Up to 90, it started to sound a little bit off to me. Like that was starting to push the bit. I'll bet you if I had space for 100, that would have been the limit. But I didn't do 100. I didn't think it would make it to 100. It's possible you could push this thing even further, but I don't know. I mean, maybe I will try that, but I'm going to be running this thing probably at 80 to 90. Again, these things in professional machine shops, they run these things up, you know, some bits up to 200 inches per minute, which is pretty insane. You know, that thing's zipping around. So a full depth cut, that's not too bad. That's a lot faster than I've been running. So anyways, hopefully you found that interesting. If not, that's fine. If so, great.